and welcome to Monday's geography session. So this week we're going to move on a little bit and we are going to think about specific structures. So last week we looked at mountains and this week we are going to be looking at the structures of volcanoes. So to look at the structures of volcanoes, we need to use everything that we have done so far this term in geography to help us. So we need to understand the layers of the earth that we've got up here. And we also need to understand tectonic plates and how they work. How, you ask me to a screen that I can't hear you, how is that going to help us understand volcanoes? Well, this is what we're going to explain. This is what we're going to do today. But keep those things in your mind as we go through. So, what do we already know about volcanoes? Now, this is just a little time for you to stop and think. You might be somebody who loves volcanoes and knows absolutely everything about them. You might be somebody who doesn't really know a lot about them. But I want you to have a pause and think, what do you already know about volcanoes? You can collect it down and write it down in your book, or you can just think about it. So pause and have a think. Gather any information you know or think you've ever heard about of volcanoes. Okay, now don't worry if you don't know a lot, because that's what we're going to look at today. So, a bit of background. So the word volcano comes from the island volcano, but spelled differently. I'd probably say it, that's probably not how you say it, because I'm not Italian and I'm not good at accents. I'm sure they say it and it sounds so much better, but it's a volcanic island in Italy. So, and there's actually a picture of it here. Looks really nice. So that's what volcanoes are named after. But the island volcano that's in Italy got its name from the Roman god of fire, who was called Vulcan, which is why, if you can see, they're spelled similarly. So the island in Italy was named after the Roman god of fire, and then this island in Italy produced the word volcano that we know today. So it all goes back to the Romans and Roman mythology, which a lot of you might be familiar with. I know that there's some people that like their myths, their Roman gods and their Greek gods. So you might already know some of this, or this might be completely new. So Romans believed that if Vulcan was made angry, the volcano would erupt. So it was him and his power that erupted volcanoes. So they tried their best to be nice to him and not make him angry. Okay, so and Roman mythology also says that Vulcan lived in a volcano. As well as being the god of fire, he made many weapons and forged them. So put them together using metal and fire. So that he was a very skilled blacksmith. And so blacksmiths are people that make things with metal. You've probably seen videos before and they're sort of melting it and burning it. So that was what Roman mythology believed. So back in the day, they believed that volcanoes erupted because of this Roman god of fire getting angry and basically erupting them. So that's where the background history of volcanoes has come from. However, there are three different types of volcanoes. I'll slide this one up so it's not underneath me. So like last week, we looked at 4 different types of mountains. This week, we're looking at volcanoes, and there are 3 different types. So 4 mountains, 3 volcanoes. Try to remember that one. So you get 3 different types of volcanoes. You get things called shield volcanoes. So they're like a bowl or shield shape, which is why they're called that, in the middle. So when they erupt, the lava is quite runny and it travels long distances down the side of the volcano before it cools again. And then the lava, when it cools, forms sort of gentle slopes that create that bowl shield shape in the middle. These types of volcanoes don't often explode, okay? So the different volcanoes are to do with their different shapes, but also how likely they are to explode. So shield volcanoes don't often. Then we've got cinder cone volcanoes, if you have a look at this one. So they're circular or oval cone shaped. So rather than pointy like our mountains, they're sort of oval shaped. And they are made up of the small fragments of lava that are blown through the air, blown into the air through a single vent. So when they cool down, they form a rock around the vent. They grow really quickly, but they're not usually really big, and they're not usually dangerous either. So cinder cones, shield volcanoes, they're not particularly the dangerous volcanoes that you probably hear and see about on the news. However, you've then got the third type, which are composite volcanoes, which are steep-sided, which look more mountainous in their shape. They're made up of lots of layers of volcanic rocks. They usually erupt in an explosive way because the magma that's in these volcanoes is very sticky. It clogs up the passageway that it has to pass through at the top. So it clogs it up. The pressure builds inside in the something called the volcanic chamber, and then the pressure builds and builds and builds, and then it erupts. So if you think of something like if you shake a fizzy drink bottle, the pressure inside is building up and up and up because there's no air, there's no space for the drink to sort of release out of. So if you keep shaking and shaking and shaking, it builds up and sometimes pops the lid off. So that's sort of like what happens with composite volcanoes, that it's trying to escape through the gap at the top, but it's clogging up the passageway and the pressure's building. And then so composite volcanoes are the types of volcanoes that erupt and that are really dangerous. So those are the three types. Try and remember the names of them, or at least the sort of description of each, what they look like or how they react, okay? As well as three different types of volcanoes, there are three different stages that a volcano goes through. So a volcano can be an active volcano, and I'm sure you've heard some of these words before. So an active volcano is one that has erupted very recently, or quite recently, and there's a possibility that it may erupt again. So it's active, okay? So it might erupt. A dormant volcano is one that hasn't erupted for a very long time, but it might erupt in the future. And there's some very complicated scientific, geographical way of working out which volcanoes are active, which ones are dormant. I don't have those skills, so I can't specifically tell you how they work it out, but there's obviously a way to work it out. And then extinct volcanoes, like an extinct animal, is one that erupted thousands of years ago, but probably won't ever erupt again. So you've got active, dormant, extinct. So you have a type of volcano, but you also might have an active composite volcano, or you might have an extinct composite volcano. So they can be different at different stages as well. Sort of like different stages in life where you sort of grow up. So you're active, dormant, extinct. So they go through those stages. Some volcanoes stay active sort of forever, for a long time, just because of the way they're constructed, where they are, and other factors like that. So now we're going to look at the actual physical structure of the inside of a volcano. Now, volcanoes come in different shapes, different sizes, types of volcanoes, but they all have most of the same features. Some are too big to be seen from the ground, and most of the actual volcano is underground. So the last time that, thinking about the volcano in Yellowstone Park in America, it's the crater, and you can have a Google of it as well. It's the crater of an enormous supervolcano, and the last time it erupted was over 640,000 years ago. Okay, so some of them are too big to see from the ground, and it's just like a giant crater, but some can be seen from the ground as well. So they've all got the same features, but whether they're visible or not depends on the volcano itself. So we have different parts of the volcano. So if you have a look, so this picture is like a volcano that's been sliced in half. So you have something here called a parasitic cone, which forms when magma breaks through the surface of the volcano somewhere other than the main crater. So if you have a look at the magma, which is coming from our layers of the earth, so it's sort of coming and shooting all the way up the middle, out the top, basically. The parasitic cone is as if there's sort of gaps in the side where bits are leaking through rather than just going straight up where they should be going. You've got the crater at the top, which I'm sure we've all heard of a crater, which is the opening that's caused by volcanic activity, so eruptions. So it's normally formed the first time a volcano erupts and is found at the end of the vent. During an eruption, the magma rises out of the crater, so rises out of here, and sort of rises out and causes the explosive eruption, the ash cloud, the lava, and everything that you would associate with a volcano erupting. The ash cloud is what sort of comes out the top, what it you see in the air. So ash, rock, and pumice are thrown high into the air during an eruption. The ash cloud was 20 miles high and entered the stratosphere when Mount Vesuvius erupted in 79 AD. So the ash cloud can be humongous depending on the eruption. So that's what is called sort of the ash that comes out the top. The vent is the opening that the magma travels up to the crater and out to become ash cloud through. So it's sort of like a long passageway that starts with an opening at the Earth's crust to the all the way up to the crater at the top. And then, of course, the bits of lava that float down the side is called lava flow, which is when the magma becomes lava and when it reaches the Earth's surface and it sort of trickles down the side, and then it solidifies and causes rocks, and it can cause build up as well. If you think back to our mountain work, some of the mountains, the volcanic mountains, were caused by the lava solidifying on the outside and building up layers. Okay, so this is what we're going to look at today. So you might want to come back and pause on this slide of the video when you get onto your work to remind yourself of the different parts, okay? Because we're looking at getting to know and identifying the structures of the inside of a volcano, as well as just knowing the different types. So what we're going to do is we're going to do something really fun, and you're going to make a fortune teller to represent parts of a volcano. Now, there is a link down underneath this one on the school website page with instructions on how to make a fortune teller if you're not sure. But I know lots of people can just make them all the time, so they're confident. But if you're not sure, follow the step-by-step guide to do that first before you get into this. So what you're going to do is you're going to make a fortune teller like the one on the screen. On the outside of your fortune teller, you're going to represent the outside part, so the things that you can see from the outside. So we've got these bits here. So we've got the vent at the top, we've got the flow down the side. So you're depicting what that would look like and labeling it, okay? And then when you open it up inside, you need to have the parts that are inside the volcano. So like the vent that goes up the middle, the little bit that goes off the side. So you need to put those. So when you've got your fortune teller closed, it just looks like the outside of a volcano. And when you open it inside, it looks like the inside of the volcano. So try to label it as best as you can. So I would come back to this slide. So inside you want sort of if you can have a look at this one, it's got the black and grey lines, sort of the layers of the volcano like this. Then you've got the vent, and then you'd need the parasitic cone inside. And then on the outside, or outside/inside, you'd have the crater and you'd have the lava flow. Okay, so that's all you're doing, is you're getting to grips with the structure and you're representing it in the form of a fortune teller. The one thing I will say is obviously a fortune teller opens different ways. So make sure that when you're drawing on it, you're clear which way it's going to be shown. So don't draw them all different ways so that when you open it on one way, there's nothing there. So I make the shape and then I decorate the outside because that would be the easiest. And then you might need to keep opening and closing it when you're doing the inside to check that you've got the parts in the right places. Okay, so follow the video to learn how to make a fortune teller if you're not sure. If you can make one, then you can just get on with it. Use colours if you've got some colours at home. If not, then just try to use shading with your pencil and label bits so that it's really just so you understand the structure of what bit is where and what is the proper names for it all. Okay, so hopefully it should be a nice and easy activity to do.